Hello, I'm Blake Cannell with Contrast Security. I'm the Director of Product Marketing for our Protect offering. And today, this session is going to cover application security. So we're going to talk about application security. It's a pretty hot topic these days, as you've noticed with recent breaches in security with the Colonial Pipeline, which is a different type of attack than we'll talk about today, but nonetheless was in the news quite a bit. So you'll be familiar with security. And so we think it's an important topic, and there's a really nice integration with PagerDuty that we'll cover. And so let's get on to our topic. Well, let's dive right into it. Again, so the topic today is looking left, looking right, proceeding with caution, and really what we mean by that is security for applications traditionally has been sort of an end of process kind of thing. So security has been done on the production side, but at Contrast, we're really big on this notion of shifting left and trying to get security built into the beginning of the process when applications are being developed, as well as on the right-hand side into production. So we'll talk about sort of both sides of the spectrum. And specifically, we're talking about application security. And one of the questions, why application security? Well, the reason is almost all applications in production, in runtime, have security vulnerabilities built into them. There's a lot of reasons for that. Part of it is the pressure to deploy applications into production more quickly for competitive reasons. There's a landscape today where there's an expectation from us as consumers to have really compelling capabilities in our applications. Of course, that puts a lot of demand on developers. So getting applications out into the marketplace quickly and other factors using code that's pre-assembled from other places, lots of custom code. These are all reasons why some applications or most applications have vulnerabilities in them. And in fact, in a survey that we did, almost 100%, in this case, 96% of applications are rolled into production with vulnerabilities built into them. So that's challenging and a big problem, of course, for folks. Specifically, if we look at a third-party survey that has been going on for quite some time, in 2020, of all the data breaches, almost 50% of them involved web applications. So malicious attackers out there are looking at web applications, looking for those vulnerabilities and trying to exploit them. And of course, that causes severe damages for companies. And again, I think I mentioned at the top of this session, the recent Colonial Pipeline breach, which was a ransomware attack, but nonetheless, very public. SolarWinds before that. So there's lots of examples, seemingly almost weekly now, where we're getting really major attacks into companies that are really paying a publicity price as well as an actual monetary price for these data breaches. So we've got almost all of our apps in production have some vulnerabilities in them, and 50% of all attack types are going after these web apps. And web apps have been the #1 target since this report from Verizon has been ongoing since 2014. It's the #1 attack target. So that's why we have a real heavy focus at Contrast Security on application security, because this is the target for a lot of attackers. And just a quick one here in terms of when we look at what's the cost to this. And again, I think the recent Colonial Pipeline, I think it was reported that they paid $50 million in Bitcoin to try to solve the problem. But here, the average cost just for a typical application, or excuse me, a typical data breach is about $8 million in the US and just $3.9 million globally, $1 million. So it's a heavy price for attacks. So if we can avoid them, that would obviously be a good thing. It would save us some money and also save our reputations, as well as make us as consumers who use these applications feel more comfortable. So application security is a big topic. So if we look at modern software development, we've all moved to different platforms to make the the sort of software factory and the software development lifecycle much smoother and easier to use. And if I build this out with source code management and different architectures like microservices, and there's a lot of talk today about, APIs is a big way to very easily assemble applications, deployment platforms, of course, people looking at Kubernetes and deploying on large environments. Obviously, if you're at this conference, you're using PagerDuty, you're in this modern software environment in terms of responding to incidents and more effectively operationalizing your environment. Analytics, there's lots of analytics, people using Splunk. So this is sort of this modern architecture and technologies that are being used. But the big question is, what's the modern application or the modern security architecture? And that's really where we come in. So as we've moved and shifted into this modern process for developing applications, what hasn't really kept up is a modern process for finding vulnerabilities as we develop code, and then also blocking and remediating attacks into those known vulnerabilities that we haven't been able to fix yet, but will in the future. So modern software security really needs to be embedded in the application. So we can't wait to do this all at the end and put up a big wall and a fortress wall and hope to keep the sort of marauding people out of the environment. We need to embed software inside the applications to more effectively secure them. So I know this is a bit of a busy slide, but kind of looking left to right, this is how we see a modern platform. It's embedded with the software applications. It's adding sensors. So basically adding, if you will, security cameras inside your application. It's not modifying the code of your application. It's just putting up security cameras, if you will, inside the applications or sensors, and then gathering this information, understanding the behavior of your application, and being better able to understand vulnerabilities as well as respond to them. So a single platform. We want this to be easy. So, it's a complex environment out there. We realize there are limits to being able to hire a whole staff of people to do nothing but focus on one specific area of software security. So we want this to be something that can be used by a broad array of people in the environment and on the teams. And it's really this notion of really adding into your DevOps environment security. So that's where DevSecOps comes into play. This ability to, again, take advantage of the modern architectures that everyone is moving to for application development and deployment, and then adding security into that. Another big part of this is being able to not only embed sensors into the application as it's being written and uncover vulnerabilities that can be fixed before applications get released to production, but also kind of on the shift right side of things, have a modern way to respond to people trying to exploit these vulnerabilities. So this ability to rapidly respond and remediate those vulnerabilities. So a big point for contrast security is this notion of embedding your security right along in your application, all the way through the lifecycle from development into production. It's a common platform and a common technology. And again, when you do this, what are some of the outcomes of deploying a sort of a modern software model? Well, here's some of the things we see. One is a big driver for people who are looking at contrast security and embedding their applications with technology to find vulnerabilities and remediate them is speed and scale. So again, I touched on it earlier. We all as consumers have expectations of great new applications with lots of capabilities. That ability to develop and deploy quickly is something that we want to not impede. And so by embedding contrast into your applications, it retains that speed and scale. Here we have a large software company that has 140 applications, and only one person is actually doing the application security for it, because again, they're taking advantage of this modern platform. Here's a big financial services company. They were able to reduce their costs of penetration testing. So penetration testing is one of those things that happens after development and you're in the QA process and you do this penetration testing, this big penetration testing effort to try to find the vulnerabilities and fix them before they go out into production, by embedding security software from Contrast inside the application, you can reduce those costs of penetration testing, because again, you're finding vulnerabilities earlier in the development cycle, and you're also able to remediate them once you go into production. And then finally, here's a large insurance company, and they were just able to increase their velocity of application release. So again, without getting stalled in sort of older processes, they're able to take advantage of that modern architecture for application development and deployment. And now they have a security solution that maps to the modern architecture. And of course, the ability, and this is a healthcare company, the ability to protect these applications. There's going to be applications that roll into production with known vulnerabilities. There's a trade-off of, again, time and rolling into production. And so this is an ability with Contrast to protect those applications with known vulnerabilities. And it buys time for development teams to prioritize the important things to fix and make those fixes and roll them out at a later date. So lots of good things, again, for mapping our security model into a modern architecture. So it's what does this sort of look like? If I build this out, there's really three big areas of Contrast. Again, the assess part is all about the sort of application security testing side. This is inside the interactive testing part when developers are writing applications. Contrast Protect is on the sort of right-hand side. It's when you roll into production to be able to examine the running application, look at the running code and prevent exploits from taking advantage of vulnerabilities. And then we have a product that allows us to take a look at open source libraries, which are frequently used by developers who are using open source libraries, bringing them in-house, adding them to their customized development efforts. And we can actually also identify some weaknesses there. So it's one technology that covers your whole application. So in the middle here, the big block, that's a typical application with custom code, libraries, frameworks, an app server, runtime. And that gets protected depending on the language you're using, Java, .NET, the Go language, which we just recently added support for. And then all that gets reported up into a console there in the upper right-hand corner, so you can very easily understand what's going on with my applications, what has been detected, what are the vulnerabilities, what are the prioritized vulnerabilities that I should be taking a look at, what has been blocked, what are just innocent probes that are coming into my applications, but what are the real threats to my application. All that is displayed in the dashboard. And again, it's a pretty simple model for doing this. It's deploy an agent to the application server. That means the agent just is adding those sensors, those security cameras to your application, and it can travel very well with your application. So it's very portable and scalable, reports all that information into the platform, as I said. And then importantly, for this conference, you can actually then tie that into those results into PagerDuty. So the integration into PagerDuty is really compelling. So we'll get to that in just a second. One thing I do want to touch on with the external applications that are rolled into production that are in runtime, just want to hit on the benefit of, again, this notion of embedded technology. Today, what we have in this graphic, which may be a little challenging to look at, is more of a perimeter security kind of defense, where you've got big barriers to vehicles, and you've got fencing, and you've got gates that are controlled, and that kind of stops some classes of attacks. But what happens if someone gets out of the car and goes over the fence or cuts through the fence and runs around some of these perimeter defenses? That's where you need an embedded security technology. So, for example, like the president of the United States has a barrier to prevent vehicles from coming near him and fencing, but he also has secret security agents right next to him, embedded with him at all times to prevent any loose potential attackers that are coming close to him. And that's, again, sort of the same approach we have for runtime applications. So in production, how this works, again, if if you look at it, that same big block, your application is running. It's got contrast agent. Someone's using on the left-hand side of the user is coming in through the cloud or through your on-premises deployment, is trying to exploit a vulnerability. We detect that with the embedded agent, and then we can report that out into PagerDuty to actionize and take action on that threat. So it's a really easy integration. On the contrast side, you can see here, it's just putting in some credentials. We have this built into our software, so you integrate right into PagerDuty very quickly. And then, of course, you can turn on and manage and configure how much the notifications and information you want sent into PagerDuty. We're very cognizant of that. We don't want to overflow information. That's one nice thing about embedding, by the way, is the information that we're pulling out of and getting from the embedded nature of our technology is very precise and accurate. So it really helps cut down on a lot of those false positives that you might otherwise get. And then finally, on the PagerDuty side, you can see here, we've got information that flows in. It talks about, here's a high urgent triaged event from Contrast Security. It was identified, a SQL injection attack. That's an attack type, very common that we can find and block, and it comes in, gives you lots of information about what's going on. So you're really getting insights into security from a environment that you're really well familiar with. So the integration into PagerDuty is terrific. That's a real quick run through on Contrast Security. If you want to take a look at this, we have a no-fee community edition that you can go to our website there, contrastsecurity.com, and go to the Contrast Community Edition and take a look at that and try that for now, and take a look at the integration into PagerDuty. Again, I showed you how simple that is. It's literally sort of username and credentials, and you can make the connection right into PagerDuty. And with that, I just want to thank you very much for taking time to spend a few minutes of your day with us at Contrast, and enjoy the rest of the conference. We appreciate it.